All right, our plan today is going to be to finish section 15.4. I'm sorry, 15.3. So in 15.3, we've been introduced you guys to the idea of a logarithm. So, yeah, they're on the ACT. How'd that go?
I got 18.
Okay.
That's a start.
It's okay, I got to college.
Yeah, you did.
It's better just to keep going.
I still baseline, I don't think so. Yeah, I actually work
So, last time was before break. We were talking about logarithms. We defined what a logarithm was. That it was essentially the answer to what power is going to give us this answer. It's like the answer to an exponential question. Today, what we're going to do is we're going to look at some properties of logarithms, practice using those. And that's essentially the gist of it. The schedule through the end of seniors is all up on my Notre Dame. That's okay. So I wrote out the schedule for till the end of the seniors, all on my Notre Dame.
When's our last class?
So it's the schedule for seniors through the end of the seniors here is all up on my Notre Dame. So there is a final test. The test date is on my Notre Dame. If you look at the agenda, you can see everything you're going to cover, everything the seniors are going to cover through the end of April. What's up?
I have a pass.
Oh my goodness. Is it for Jacob? Isaac Jacob. We knew it was you.
Have a good day.
You too.
Thank you.
Okay. So we're going to see 4 properties. The first property is the product property of logarithms. What that says is that the product inside a logarithm is the same as the sum outside the logarithm. Note, this is the equivalent of this property of exponents. Okay. We also have a quotient property that says division inside a logarithm is the same as subtraction outside the logarithm. Again, this is equivalent to the exponent property of division. Because remember, a logarithm is just like a recasting of an exponential equation, right? That was our definition. So all these properties of logarithms are just the corresponding version of an exponential property. The third is the power property. That says that an exponent inside a logarithm can become a coefficient outside the logarithm. That's the equivalent of the exponent of an exponent property. And the fourth property is called the change of base formula. Yes.
Could you please sync the OneNote so I can see it?
It should be syncing right now. I have it set to do that. So I don't know. Might be your end.
Yeah, I tried to resync it though.
You should just stop this.
No button is out. I'm leaving to register. She told me it all. Yeah. So she on the registration. I really pray for me. Like save for me at 3 p.m. Everyone in this class save for me. I got
Why?
I have to register for college classes and I need to make sure I get into them. Like I have to be on them.
What college classes?
Florida Atlantic University. I speak to in the summer, so I have to make sure they're online.
Well, good luck.
Thank you.
Is that where you're going to do now?
Yeah.
Okay.
Did she even ask for AAA?
She was marked absent. Like I knew she was leaving. She's really, I know, going home to take a nap or something, but
Yeah, I think you're aware though.
yeah. And the change of base formula doesn't really have a direct exponential equivalent to it, so I'm not going to bother. So there are two types of problems that we'll ask you to do. These are problems that will occur on your test for sure, that are going to just test explicitly if you can use and understand these three, or the first three properties of logarithms. So those two types of problems are expand, which means we're going to take one logarithm and turn it into many, and then condense or compress. You could see that either word used. Here we're going to take many logarithms and try to turn it into one logarithm. Is everybody okay with the idea?
Yeah.
For expanding, we're going to want to go quotient, product, power. And when condensing, we're going to want to go the opposite order, power, product, quotient. Unless there's some set of parentheses that dictates you should use a different order, right? But if there's, as long as there's no parentheses, that's the order in which we want to use these properties. Yes, Emma. Okay, no problem. So here we're going to do some examples. And then we're going to kind of sit here for a minute and soak this up. So the first type of examples we're going to do are expanding. Actually, let's do that. So our first example is going to be log base 3 of 5x squared y. So when we're doing an expanding problem, first thing we look for is a quotient property. So when we're doing expanding, we're looking from this side and trying to go to the other. We're going to start with the 1 log and try to break it into more than 1 log. Is okay? If I look at our problem, do I see any division going on inside the logarithm? Right? If I look at 5x squared y, is there division there? No. So there's no quotient property to do. Everybody's okay? The next thing we're going to look for is a product property. So if I go and I look at the product property, here we're going to be looking for multiplication inside our logarithm. Do you see multiplication going on inside our logarithm? Yes. How many multiplication symbols are there? 2. Where are they at? In between the 5 and the x squared, and between the x squared and the y. Does everybody see? So how many product properties are going to happen here? 2. Okay? So what I'm going to do is I'm going to write like product property times 2. So that as you're doing this and going back and looking at your notes, you understand what I did here. Do you have to do the same thing on your homework or your quiz or your test? No, this is just me trying to help you when you go back and look at these things. Everybody's okay? All right. So everywhere where there was a multiplication symbol, we're just going to make a plus sign. And you have that log base 3 around each of those things. Is everybody okay with what I did there? So that log base 3 is wrapped around each of the 3 factors, and each factor is inside gets broken out of the logarithm, right? Does that feel okay? Okay. The last thing we look for now is a power property. So for a power property, We're looking for a power inside the logarithm. So if I go and I look, first thing we'll do is we'll look at 5. Is there a power on that 5? I mean, there's 5 to the first, but the 1 doesn't really matter to us, right? So we'll just ignore that. Is there a power on the x squared? Yes, so we'll have to do a power property there. Is there a power on the y? No. Okay, so we have one power property that's happening. So I'm going to leave a little space to write in that new part. But the other two pieces did not change, right? Everybody's okay? Just the part with the x squared is going to change. Let's go back and look at what the power property says that we need to do. So if I look at my power property, it says that the exponent is going to turn into the coefficient. Okay. Well, the exponent here was a 2. And we're done.
That's the answer.
That's the answer.
So is the product and the power the like answer?
So your answer is what's boxed.
Oh, you're okay.
So that's the idea for an expanding is we're going to take one logarithm and break it up into as many logarithms as we can.
So you just use the properties to find the power.
And we use the properties, those 3 properties, to break it up. That's what allows you to break it apart.
You did that because there was multiplication inside the quotient.
Correct. And then there was a power attached to one of the multiplication pieces. Okay? We'll do some more examples of this.
And then if there was multiple powers, then you would have to you'd have to change every power.
Mm-hmm. Yep. We're going to do some more examples.
Oh, no. Okay. What this house?
Okay. So let's look at our next example. Our next example is ln square root x over y squared z cubed. These are expanding problems, so the first thing I look for when expanding is the quotient property. If I look inside that logarithm, is there any division going on?
Yes.
Yes. Where's the division going on?
In the base.
The fraction, right? So what we're going to have is going to have natural log of the top minus natural log of the bottom. So where the division symbol is, we replace with a subtraction, and then the logarithm wraps around the 2 parts of our division problem. Is that okay with everybody? Okay. So we had one quotient property there. All right. What do we look for next after quotients? We look for products. Okay. So if I look at the first logarithm, inside is the square root of x. Is there multiplication there? No. Right? So that's not going to change. If I look at the second logarithm, y squared z cubed, is there multiplication going on in there? Yes. How many multiplication symbols? 1, right? There's a multiplication between the y squared and the z cubed. So that's going to break them apart at the multiplication symbol. We're going to put a plus sign there. And the log wraps around both factors, right? Is everybody okay? Now, the way I've written this is wrong. I've written it wrong on purpose because this is the most common mistake that students make in this type of problem. Take a moment and look at what we've got here. There is a mistake I made going from the previous step to this step. See if you notice what it is. It's subtle, and I'm making a big deal out of it because this is an incredibly common mistake that students make. What's wrong with the signs? Well, the subtraction is from the quotient property, right? So that subtraction is that subtraction. Yeah, so Gabby's got it. So here's what's going on. This logarithm, the entire thing is negative, correct? Because there's a subtraction symbol in front of it. So when I apply the product property, the result is negative. So there's like a missing set of parentheses. So this negative sign should distribute through. And that should be where we're at. Now, what I would encourage you, the easier way to think about it is, see how we have a product property or a product in the denominator? Anytime I have that, I'm going to have minuses instead of pluses in my product. That's all I'm going to remember. Okay? Now, it's because I have to distribute the negative through, and I want to show you that first, but in practical terms, whenever I have a product property in the denominator, I'm just going to write subtractions instead of additions. Is everybody okay? That's my cue. All right, continuing on. We've done our product property. We've done our quotient. We've done our product. What's the last thing I need to do? Power. How many power properties do we see here? 3 is correct, Gabby. Does everyone see the third one?
Yeah.
What is it? The square root is what power?
1.
Yes. So we have a power property times 3. Does that feel okay with what we did there? Oops. I shouldn't because I wrote a plus there when I meant to write a minus. Does that feel okay? Probably a little better, right? Now that the correct answer is there. Little tip for you guys, helpful hint. Expect to see one where you have to distribute that negative in the denominator on the test. Should expect to see that. Just as a heads up, that trick will end up on the test. Not that it's that hard of a trick, but hey, it's nice to know to expect it, right? All right, let's do one more example. Yes. Let's do. Let's do this. Okay. That's y times z. Hopefully it looks like they're on the same level and one isn't the exponent of the other. I hope my penmanship's not that bad. I admit that it's not great, but it's good enough. Thank you. I appreciate the low bar there.
You're welcome.
All right. What should I what should I do next? Or what should I do? What do I do first here? Quotient rule. Very good. How do I write this then? I'll have log of the numerator
I knew it was a tough crowd today. It would have been laughing.
minus log of the
Goal.
denominator.
Do I have on Snapchat? Actually, you don't have. Mine's missing Snapchat.
I think I have one Snapchat.
I don't have on Snapchat. Wait, Danny, is his full name like Danielle?
Oh, yeah. He's in West Bloomfield.
Daniel's not his name. He's like Dan the man. Dan the man.
All right. What's next? Product property. How many product properties do you see? Two, right? One in the first logarithm and one in the second logarithm. Everybody agree?
Yeah.
Now there's a little hitch here though.
Oh dear.
What's the hitch?
Well, Y times Z.
Yeah, what's the problem with the y times z? It's inside the square root, right? So we should be thinking about this as like a set of parentheses there, right?
Yeah.
So should I be doing the product property yet?
No.
No. What do I have to do before I can get to that product property in this case? I have to do that power property first. So I'm going to leave that for now. I am going to do the product property for the other one. Is that okay with everybody?
Yeah.
Okay. Now, I'm going to go ahead and write that first logarithm in that way that I just showed you guys so that we remember to do that. What do I have to remember with that second logarithm, though, when I do the product property there? Distribute the negative, right? So it should be minus instead of plus. Everybody's okay?
Yeah.
All right. Next up is the power property. How many power properties do you see? Depends on how you're looking at it. One is fine. The one you see is the power of 1/2, correct? Everybody's okay?
Yeah.
Now that we've done our power property, we can go ahead and do that other product property now. And just like before, where we had the product property in the denominator, that product property needs a parenthesis around it because that 1/2 out front needs to distribute through. Is everybody okay with how we've gotten to here? Looks pretty done, right? There's something hiding that we can still do. Take a look at it because it's quite tricky. I'll give you a hint. That's the piece.
Oh, doesn't that simplify?
Yeah, doesn't that simplify to something? It certainly does. How do I need to rewrite this so that I can simplify this logarithm? When I write log with no subscript, what is the base of that logarithm that we know to be there even if we don't write it? 10. Very good. As in a separate aside. What is the name for that logarithm? It has a name when it's log base 10. It's called the common logarithm. So that's the first step. You got to recognize that that's log base 10. Now, to simplify this, I need to rewrite 100 as a base 10 number. 100 is 10 to what power? 2, right? Is everybody okay there? And what's the relationship between log base 10 and exponent base 10? They cancel. There's our final answer. That's going to be by and large the most complicated this kind of problem can get, right? We had everything kind of going on in there. We had a different implied order. We had to distribute that negative. We had a reducing mixed in there. That's as like all the tricks that I could possibly play on you all combined into one problem. Would you get something with all the tricks in this one problem on the test? No. Would you see all the tricks in separate problems? Probably. No, this should feel okay, right? This should feel okay. Yes. Yeah, it helps that it's like kind of all the same. Yes. Yes, that's exactly the way to think of it. All right. So that's expanding. The opposite side of that coin then is condensing or compressing. Let's look at some examples of this now. Bless you.
Not allowed to. Springtime is
So in condensing, we're trying to accomplish the opposite, right? We want to take a bunch of logarithms and squish them together into one. So we're going to be using those same three rules of logarithms, but we're going to follow them in a reverse order. So instead of going quotient, product, power that we do for expanding, we're going to go power, product, quotient when condensing. And instead of reading our properties from left to right, when we're expanding, we're going to read them from right to left when we're condensing. Is everybody okay with this plan? All right. So when we're condensing, first thing we're going to look for is power properties. So for the power property, I'm going to look for coefficients in front of our logarithm, and we're going to rewrite those coefficients as exponents inside the logarithm. Is everybody good with that first plan? All right, let's take a look. Do I see any power properties that I can do? Yes, I see one because I see a coefficient in front of my logarithm. So the other two logarithms are going to stay the same. But that one with the power property, I'm going to smush that exponent, or make that coefficient an exponent inside the logarithm. Is everybody okay that what we're doing? So not only are we using a reverse order, we're using the properties in the reverse direction also, right? Okay. So no more power properties because I have no more coefficients. The next thing we're going to look for now is a product property. So if I look at here, we're going to be looking for addition between the logarithms. So if I look, do I have any power property or product properties going on? Product properties. Yes. How many product properties do I have? One, because of the addition. So the product property is going to take that addition outside the logarithm and turn it into multiplication inside the logarithm. Is everybody okay with how we did that? Now our last step is going to be quotient property. Where did you go? There you are. If I look at my properties, the quotient property, I'm going to be looking for subtraction between the logarithms. Do we have a quotient property going on? Yes, I do. So the positive part of my quotient property becomes the numerator, and the minus part of my quotient property becomes the denominator. How do you guys feel on this? It's okay? All right, let's do another.
Thanks. You guys are the soldiers. It's more like
You just know how you tend to favor it higher than what are you saying?
All right. So here's our next example. We're condensing. What is our first thing we're going to look for when condensing? Power property. How many power properties do we see? We see 3 because I have 1, 2, 3 coefficients. Okay, remember in the power property, those coefficients are going to turn into? The coefficients turn into? Exponents. Now notice one of my coefficients is a fraction. What is that going to be? The fraction is 1/2. 1/2 is the same as a square root. So I'm going to write it that way. Okay. What do I look for next? Product property. How many product properties do you see? 1, correct? Because you see 1 addition symbol. Do you guys agree? Okay. What are the 2 things that are being added?
The log 3 square root x with log 3 over z 7.
No.
Oh.
Yeah. So Nick, I made this problem in particular because this is another really common mistake that students make, and unless you point it out, most students are going to overlook this. Okay? Let's look very carefully at the product property as stated up here. Notice when I look at the product property, both of these logs are positive. Right? I have positive log base b of r plus log base b of s. So if I look down here, this log is negative. So the product property is actually happening between those logs. Notice that because I'm talking about addition, does it matter where I write that plus log base 3 of z to the 7th? No, right? I could write it right next to the log base 3 of x to the 5th, which is the way I'm going to think about it. So again, very common mistake if it hasn't been pointed out to you. Should you expect to see this trick on a test? Yes, right?
I should expect it. But I'm gonna put that 20 just right.
Well, it's one of those where it's like, hopefully the tricks make sense as to why, like, oh, I see why I have to do it that way. Everybody's okay? All right, last step would be quotient properties. There's just one of those. Oops. What happened to my y? Where did that go? Oh, this is supposed to be a y. Yeep! Okay. So far, so good. Let's do one more example of this. Let's make that a different number. Boy, that is a funny laugh.
Boy.
All right, we're still condensing. First up is power property. Good. But hopefully, did you notice anything weird about this one that's not like the other ones? Yes, what do you notice, Gabby? Yeah, like, what do I do with this? How do I rewrite this 5 as a log of something? So let's go back and point this out to you guys. Okay? So when we did example C for expanding, remember we got to the very end and log base 100 turned into 2, right? You guys remember doing this? We're essentially going to reverse engineer this same process to turn that 5 into log of something. Okay? So let's look at the process that happened. So log of 100 became log base 10 of 100. Then we rewrote 100 as base squared, and then we canceled the exponent base and the log base. Is okay? So let's go back and look at this one here with the 2, or the 5, excuse me. So the logarithm in this problem is ln. What is the base for that logarithm? Not 10. That's, yes, it's E. So ln is log base E. So 5 then is going to be the same thing as log base E of E to the 5th. Because I know that like log base E would cancel with exponent base E, and we'd have just 5 is equal to 5, right? Is everybody okay there? And then instead of writing this as log base E, I'm going to just write it then as ln. Okay. Now let's hit those power properties. You guys hopefully see 3 of them. 1, 2, 3. Everybody okay here? Okay. What do we look for next after power properties? Product properties. Very tricky. Promise you'll see the same trick on the test. How many product properties do you see? 2 is the correct answer. Mr. Kulik, I don't see a single stinking plus sign in this problem. How are you telling me there's 2 product properties floating around in here?
Oh, because the exponents.
So if I factor out a negative, I have this, right? Yes. And now, aha, I see my 2 product properties, right? But what's the takeaway here? Do I really need to write that intermediate step, or can I just recognize if I have multiple subtractions that are just all going to go together into the same logarithm, like a product property works, except I'll have a negative sign out front? Right? Everybody see that? Will you see on your test a problem with multiple subtractions in it? Yes. And then my last step is to quotient property this. What do you guys think? Okay, so I've shown you all the meanest tricks now. We have one last thing to show you. And that's just using the change of base formula. All right, so let's say that we have log base 3 of 10. If I look at the change of base formula, what it says is I can rewrite log base b of r as log base a of r divided by log base a of b. And with the change of base formula, here's the good part. When we apply the change of base formula, it's our choice for the base of the new logarithm. What do you suppose we want to use, or what base do you suppose we want to choose? There's two reasonable choices. 10 or 1 is not a viable base. That's an illegal base for a logarithm. 10 or nope. 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 0 is an ineligible base also. Nope. E. E is the other one. Okay. Shh. Why 10 or E?
No, you're wrong.
No, E is an irrational number like pi is. So it's like, no. I didn't miss what she said also. Can we put her something? Put her away? I don't know where you're going to put her.
Yeah. Who? They're gonna put me down, yeah. That's not exactly.
If we just trap her in a locker form, then we'll be fine.
I adore her. That's not happening.
Okay. So why 10 or E? That's the question. The answer is because your calculator has log base 10 and log base E as a button on them. Does it matter which one you choose to use? No, man, it doesn't.
I did not say that.
So I just pull out my calculator then. Log 10 divided by log 3. There's my answer. Note that this is the same thing that we would get if we did the math button and then pick the log base command. And it's the same answer we would have done if we did natural log 10 divided by natural log 3. Right? Yes, go ahead. Okay. So the person in this room where the change of base formula is going to become critical is Gianna. Why is that Gianna? Because she has a crusty old calculator that doesn't have the log base command built into it. She has a very old operating system calculator, which is fine. It can still do everything you need it to. Just doesn't have all the commands. Yeah. She has extra steps.
I'm just gonna steal yours.
That's fine. You can do that too. I told you the same thing.
Yeah.
Okay? So for the homework, when it asks you to use the change of base formula to do it, it's literally just, log 10 divided by log 3 or natural log 10 divided by natural log 3. It doesn't matter. No. Could you do something real silly and do like log base 2 of 10 divided by log base 2 of 3? I mean, yeah. It'll still come out to be the same thing, but like, woof, that's pretty silly because you had to use the log base command to do that when you could have just typed the thing to do the log base command anyway. But it doesn't matter. The point of it is that the base is your choice. You can pick any valid base. And that's it. What do you guys think? We happy for today?
Yeah, that's pretty simple for the most part.
I agree.
So your assignment for this class is, I don't want to do that right now. No. Okay. So you guys should be able to do then 71 to 98.
Charlie was gonna make up a fake injury to skip today, but he won on
Wow. Just tell them already that you can't want.
Those are all expanding, condensing, and change of base formula problems. Sunday at midnight.
Maybe it's in the bathroom.
Yes.
Yeah, I mean, that's not-
You got me.